Hello everyone, and welcome to our lesson on exponential manipulation. Our learning target is I will be able to rewrite exponential expressions in equivalent forms. Now, this is going to seem like a very brief lesson, but please know there's actually a lot going on behind the scenes. Both where these rules that we're going to use to rewrite expressions come from, which we'll do some work on in class, and then really there's no examples in this video because it comes down to just practice applying the rules in different contexts. Once again, that we'll be doing in class. So this video pretty much just covers like the essential knowledge that you need to know in order to do this, but there's going to be a lead up to this knowledge, as well as then applying that knowledge in a bunch of practice scenarios to get more comfortable with it. When we say something is an exponential form, there's going to be a base and an exponent. And if a number is an exponential form, the exponent is going to represent the number of times that the base is to be used as a factor. So a number produced by raising a base to an exponent is called a power of that base. And for example, 81 can be called the fourth power of 3 because 3 to the fourth power, or 3 times 3 times 3 times 3, is going to be equal to 81. Here we have a bunch of expressions written in exponential form and expanded form. Now, anything in red was missing from our tables and our notes, so feel free to fill those in. But 4 times 4 times 4 times 4 times 4 can be written as 4 to the 5th. When I have 1/2 to the 6th power, that's the same thing as 1/2 6 times being multiplied. And then I hope you notice an important distinction in the third and fourth examples. Here I have 5 times 5 with a negative in front of it. So I can represent that with negative 5 squared. And here I have negative 7 with a 4. So everything in the parentheses is being raised to the fourth power, which is why we have a negative 7, negative 7, negative 7, and negative 7. Here we only have one negative, so it's not part of our, it's not being raised to that power. Here we have something being raised to that power, so it's going to be appearing that many times. Important distinction there where the negative falls. All right, and let's dive right into our exponent rules. The product rule states that if I have two expressions with the same base and I multiply them, that's going to be equal to an expression with that base to the a plus b power. So if I have x to the a power times x to the b, well, that's the same thing as x to the a plus b power. Now, if I have something raised to a power, then I'm going to go ahead and multiply those exponents. If I have two things raised to the same power, well, then that's the same thing as raising one thing to that power and multiplying it by the second thing to that power. That's known as our power rule. There's a couple different ways of looking at that. Our quotient rule is when I'm dividing two things. Well, this is the opposite of our product rule where we added. So when we divide, you can go ahead and subtract those exponents, and it's equivalent. What if we have an exponent of 0? Well, anything to the 0 power is going to be equal to 1. So you can go ahead and just replace anything to the 0 power with a 1, and it helps us simplify expressions pretty rapidly. A negative exponent can be rewritten as a positive exponent by bringing it to the other side of some fraction, either down to the denominator, or if you have a negative in the denominator, you can bring it up to the numerator and it magically becomes positive. Now, this isn't magic. As I said, with our investigations, we're going to see why this is true, hopefully at least derive this rule. But for right now, we can plainly say that if we have a negative exponent, bring it down to the denominator and it becomes positive. If I have a negative in the denominator, I can bring it to the numerator and it becomes positive. Last but not least, a rational exponent is when we have an exponent that is a fraction. If I have something to the 1 over b power, that is the same thing as the bth root of x. So for instance, 1 over 3 would be the third root of x. 1 over 2 would be the square root of x, and so on and so forth. If my fraction has a value other than 1 in the numerator and then b in the denominator, it's the same thing as raising that to the power of the numerator, and then the denominator represents what root we're looking for. All right, that's it. I hope this video was helpful, walking you through all our exponent rules. Please let me know if you have any questions or concerns. I look forward to working with you in class. Take care.